Today's day 5 of Unit 11 on comparing functions. Before we get started, let's go over the homework or classwork from yesterday's lesson. So for number 5, these are both set equal to y already, so you could just set them equal to each other. Remember, we set them equal to each other, then set them equal to 0, and then we solve. So for this one, we actually could stop there. Once we found the x values, that's all that this question was asking for. So your solutions were 4, -1, or I'm sorry, x equals 4 and x equals -1. And if you did write 4, -1, just remember it's brackets, or braces rather than parentheses, because parentheses looks like you're saying it's a coordinate. All right, for question number 6, this one, I tried to help you set it up real quick. There's a couple different ways. I told you to please try and always keep your x squared negative. So some of you actually subtracted all of this side, or added and subtracted, over to the other side to keep it positive. But if you don't, just remember that once you do this, see how I multiplied it by -1? Because if you multiply the other side by -1, it just equals 0. You could also have done the x method if you wanted to, but if you just multiplied everything by -1 on both sides, it would take you, I'll just show you what that looked like. So it would end up being x squared minus 11x minus 60 equals 0, and then x minus 15, x plus 4, so x would equal 15 and -4, which you would reject. So that's kind of the way that I told you to do it yesterday, but if you wanted to do the x method, you definitely can do that, and then you would factor by grouping. Remember, Part A wanted to know the x value because we're talking about days, and then if you substitute that back in, you would get 424 people. And remember, you only have to substitute it into one, but if you do it to both, then you would just see, if you get two different answers, maybe your x value is wrong. Okay, so our last day of this unit is going to be about how do we calculate and interpret the rate of change over an interval of a quadratic function. So basically all that is depending on what type of function, this is usually referred to as the slope. Okay, so for the do now, you had to identify the rate of change. Some of those are easier than others. For example, number 1. So if you think to what a rate of change is, remember, rate of change, we always circle back to it being a slope. Okay, so if you notice this is a linear equation, a linear function, they also told us that they're all linear. Okay, so be careful of that, especially when you get to B, you guys don't have to guess which type of function it is. They're telling you it's linear. So remember, m is going to be slope. So because m is equal to 2, that is your rate of change. Okay. For this one, we are going up by 1 each time, and up by 3 over here. So remember, m is also equal to the change in y over the change in x, which equals 3 over 1. So for that one, m is equal to 3. Okay, that would be B. And lastly, for this one, it's a little bit hard to see, but you could definitely point out some. So we got 0, -2, and then it goes up 1 over 2. Come on. Okay, up 1 over 2. So plus 1 and plus 2. So again, if you do the change in y over the change in x, this is equal to 1/2. Okay, so 2, 3, and 1/2. Those would be the rate of change, also known as the slope. Okay, so just to kind of recap, so the rate of change, again, is equal to the slope, just as we said. So the change in y over the change in x, this is called a delta. We've talked about this, so it just means the change in, so the difference. And the formula is y2 minus y1 all over x2 minus x1. And these x's and y's represent coordinates. Okay, so for a linear function, the rate of change is constant. For a quadratic function, we have to find the average rate of change between 2 points. Okay, so between 2 coordinates. So it's not really very different, but for this one, it's just going to be, we're going to find it a little bit differently every time. So for number 1, an astronaut drops a rock off the edge of a cliff on the moon. The distance dt, remember d of t is just another way to say y, in meters, the rock travels for t seconds, can be modeled by the function 0.8 t squared. So what they want to know is they want us to figure out the difference between at 5 seconds and at 10 seconds. So actually all we're going to do is we are going to figure out the coordinates at 5 and 10. Now you can simply do, d of 5, so 0.8 5 squared, okay, so find what that equals, and then d of 10, so you can substitute those in. Okay, but another way is you could just put them into your calculator. Alright, so I'm going to leave that for a second until I grab my calculator. So all we're going to do is we are going to subtract these. So we're going to do y2 minus y1 all over x2 minus x1. So we know our x's already, so I'm going to do 10 minus 5. And then on the top, so if you type this in, so 5 squared would be 25, and then times 0.8 would be 20. And then this would be 100, so this would be 80. Okay. So 80 minus 20, which equals 60 over 5, so that equals 12. So m is equal to 12. Okay. Also, you could put this into your calculator. So if I put the function into my calculator, this is just instead of doing all of the math, you could put the function into your calculator, go to the table, and then you look at when x is 5, it equals 20, and then when x is 10, it equals 80. So you don't have to actually do all of that math. You could just write the two coordinates and then substitute them into the slope formula, and you would see that 12 would be the difference. So that would be the rate of change. The rate of change. So we're finding the average speed. When they say average, you should automatically know you need at least two things to be comparing. They gave you an interval of 5 to 10. Okay, so here's another way that they could present this to you. So they gave you the function. Doesn't matter what the function is. They want the average rate of change from 1 to 3. So what that means is you're going to circle when x is 1 and when x is 3. So this will be your x2, x1, this will be your y1, y2. Remember, when you get an average rate of change, we are going to try and just keep it positive, but it ends up working out even if you do it in the wrong order. So if you're asking yourself, well, how do I know which one's x1 and which one's x2? I usually just go in order and then subtract. But remember, if I did do, let me just set it up so you can understand what I'm talking about. So y2 minus y1, don't forget to write your formulas every time, because, again, it has nothing to do with me just being a stickler for making you do more work. because I swear that's not my final goal. The reason for that is if you write down the wrong formula, like let's say you put x2 minus x1 on top and then y is on the bottom, if you follow through the whole way down, you'll get more points than if you just put random numbers in. So if I can see what your, and this is not just me, this is for the regent too. If you follow through with the formula that you give, you'll get some points because you did a correct process, but your starting point was wrong. So the next thing I just wanted to point out was if you did reverse the order, just make sure that the coordinates are like over top of each other. So like 316 goes with and 1 4. So if you did do 4 minus 16 and 1 minus 3, you'd just get negative 12 and negative 2. So it'd end up being 6 still. So there's not really a way that you could mess that up. All right, number 3. So Joey enlarged a 3-inch by 5-inch photograph, and we want to know the average rate of change of the area, and we want to do it to the nearest tenth. So it says from the original to the 4th enlargement. Okay, so the original is going to be like where it starts, so at 0, and then the 4th enlargement is going to be at the end. So actually all these numbers don't matter. So again, I'm going to do y2 minus y1. The other reason, remember this is one of the formulas that you are not given. So by writing it down time after time after time, you're automatically putting it into your memory. Okay, so this would be x, this would be y. So I'm going to do 36.6 minus 15 all over 4 minus 0. And if you think of this, so this is kind of referring to time. So the first time, the second time, the third time, the fourth time, so that's why it's x. Okay, so if we subtract those, we would get 21.6 over 4. So m is equal to 5.4. And that's the rate of change, average rate of change. All right, so question number 1, we did this algebraically with the interval. This one I'm going to do using the calculator. So if we're trying to find the average rate of change, you're going to put this into your calculator. And these are the x values you're going to try to find. So I'm going to go, I put it into the calculator, and then I'm going to go to the table. Okay, so I first want to go to -1. So I see that at -1, okay, so my first coordinate is going to be -1, -2. And then my second coordinate is going to be 433. 433. So this are the only numbers that you're dealing with. Okay, so again we'll say x1, y1, x2, y2. Now you might be asking, do I have to do that? Of course not. But again, it makes it a little bit easier to set this up and to commit this to your memory. So 31, be careful with these. So I'm subtracting a negative. Same thing in the x's. I'm subtracting a negative. So remember, when I'm subtracting a negative, I'm really adding. And you can put this literally right into your calculator. Okay, I mean, obviously I don't like you guys using this as a crutch, but that's not what I see it as. It's a resource, so use it. So literally do, so minus, just remember the minus sign and the negative is different. And then put this in parentheses, and it will automatically do that for you. Okay? Now, of course, I would hope that you guys can do that in your head, but I know some of you you don't trust yourself unless it comes out of the calculator. Okay, so my average rate of change is going to be 7. I don't have to put units, I don't have to do anything like that, because they just want to know this, and they didn't give me any units. Alright, so number 5 is a multi-step question. What they want you to do is, not only do they want you to find each of the average rates of change, but they also want you to compare them and put them in order from greatest to least. So I'm going to find this one first because we're going to use the calculator. Okay, so what am I doing? So table, Alright, and they told us the interval is from 0 to 3. So those are the coordinates I'm going to get. So I get 0, 0, and 3, 3. So those are my coordinates. That's all I need from the calculator. Okay. Oops. Alright, this one we use these two coordinates. And then this one is going to be 0, 2. And 3, 9. Okay, so I just went through and again double check. So this says greatest to least. So make sure you put a box around that, and then you know what interval you're on. The only reason for this is if you write it, if you do all that work right and then you do least to greatest, that's just such a bummer. Alright, so I'm just going to write the formula up top here, so I don't have to write it 3 times. Okay, and that's still fine. Alright, so I'm going to do 3 minus 0, and then 0, minus 0. Oh, I did that wrong. Too many zeros. Okay, so 3 minus 0 over 3 minus 0, which equals 3 over 3. So for g of x, m equals 1. Alright, for f of x, so see how this says f of x, and then this says h of x. So keep them straight. So this one is going to be 7 minus 1. Remember, this is the same thing as y. So 7 minus 1 and 3 minus 0. So m is going to be 6 over 3, which is 2. So far, f of x is the biggest. And the last one, m is equal to 9 minus 2 all over 3 minus 0. So that would be 7 over 3. If you can't do that in your head, so 3 goes into 7 evenly twice, and then there's 1/3 left over. So that one's a little bit bigger. So my order is going to be h of x, f of x, g of x. That would be the order from greatest to least. Greatest to least. Okay, so the last one I'm going to do, then you're going to do 7 and 8 together with your groups. We're going to consider the quadratic function. We're going to find the average rate from 1 to 3. So let's go ahead and find those coordinates. So 1, 0 is the first coordinate, and then 3, negative 4. And you can go right ahead and write them right on your graph. So m is going to be equal to negative 4 minus 0 all over 3 minus 1. Okay, so that's going to equal negative 4 over 2. So if we simplify that, m is equal to negative 2. So there's our average rate of change. Remember, pretty much the slope. And now, our favorite thing, increasing or decreasing. So remember, we always read our graph from left to right. Okay, so I'm going from here all the way down to here. Okay, so we want to know, is the function increasing or decreasing? Over that interval, it's going down, so it is decreasing. Again, we read from left to right, so we'd be going down over here, and then as soon as we get to 3, we're going up. Okay, so our in-class practice is going to be 7 and 8. This is not homework, this is for you to do right now, and we will go over it at the end of class.